Coming up on today's show, I'll be revisiting some older recordings that I did discussing the topic of how did we get here with plastics use? My thoughts only, but I think there's some good stuff here. So why don't you come along and give a listen? Welcome to the show. I'm your host, Kurt Stahle, that plastics guy. If you're new to the show, this is where I share my almost 4 decades of plastics industry experience with you. I'll educate, interview, share case studies, showcase innovative products, and always discuss the topics and trends that affect our industry. Today's podcast is sponsored by Polytivs. Polytivs out of Germany make a very unique additive that will help you boost strictly the melt flow of material. So if you're a compounder and you're faced with buying feedstocks from different suppliers or having to do opportunistic spot buys, we call them, but the melt flow isn't quite right, I've got a product for you. We're going to be rolling it out over the course of the fall and into 2026. So that's Polytivs in Germany, distributed in Canada by my company, Simco Plastics, where we truly have a passion for polymers. Find us at simcoplastics.com or contact us at info@simcoplastics.com. So years before I started this podcast, That Plastics Guy, which again, thank you very much for tuning in and supporting the channel and liking what I have to say. It means a lot to me. Truly, thank you. Several years ago, before starting this, I filmed a series of videos, I want to say maybe in the 2017, 2018 area, where I wanted to start tackling some of my thoughts around plastics, recycling, plastic waste, what we're seeing in the environment. And I guess just it's a combination of trying to defend some of the things that our industry does, and I think does very well, and I'll get to that in a moment, and trying to highlight what we as humankind are not quite doing right. And that has a lot to do with littering and not recycling, et cetera, et cetera. But I wanted to revisit a series that I did. I think it was 2-part, and it was plastics. How did we get here? May have been 3-part, doesn't matter. And I think the thoughts that I had then are worthwhile repeating, because if you work in our industry, I mean, certainly it's your livelihood and you don't want to see things happen to our industry that will make it go away, and we don't need more job loss in Canada. We don't need job loss anywhere in North America. I mean, we're all in this together, regardless of what you might think. If you're south of the border and you're listening to this and you happen to be part of a certain administration, we are all in this together, and we need North America to be successful. We need it to be efficient, and we need to get people working and keep them working. And the plastics industry does provide jobs. It provides a family of products that are core commodities that we use to build the things that we use day in and day out. So, asking the question, how did we get here? Well, I guess you could say it all started in the mid-1800s, give or take, with a product called Bakelite. And I'm sure some of you might be familiar with that. It was a rather fragile plastic. It was used, I believe, I want to say 1900s. It really became commercially successful in 1900s, 10s, 20s, 30s, 40s. I have a Brownie camera that I'm very sure was made with Bakelite components. Quite famously, the Eastern European car, the Trabant, made extensive use of Bakelite in switches on the dash as recently as, well, in the 1980s, prior to the fall of the Soviet Union. But if you look in automotive industry, of the appliance industry, plastic knobs, they were done in this Bakelite product. And as I mentioned, it's not exactly the most robust product, but it was a fairly simple thing to develop. During the Second World War, nylon was developed as an alternative to real organic silk, for parachutes. During the war effort, we had to, go away from these things that were organic based, and that was one of the things, one of the solutions. And of course, rubber goods were given up. Chrome plating, that was for the time being, when cars were produced, I think for about a year and a half into that conflict before the U.S. joined in automotive production, stopped in 42 model year. Chrome was pretty much gone. A lot of paints were gone. There were scrap drives for metal. And, I think it was fair to say at that point in time, plastics really started to come into their own. So we were developing, and by the way, if you want to get into the specific start times and the commercialization times of polypropylene and polyethylene, please feel free to do that. I'm not trying to give an overall history lesson on polymers, even though it is quite a fascinating thing to look at. And every polymer has its champions in certain chemical companies. And I think I did talk about a couple of them in various podcasts I've done. But the point I want to make is polymers were developed because there was a demand for synthetic alternatives to organic materials that could be produced cheaper, could be produced in greater volume, could be distributed easier, could be stable during production, transportation, and fabrication in plastics processing equipment. So great. I mean, that makes an awful lot of sense. And if you're in the industry, you certainly know this. If you're listening to this as someone outside of the industry, what we've done is create a family of materials that have highly specialized physical property traits that offer more freedom to designers, builders, everyone involved in supply chain, creating products that can really adapt to what we need. Now, case in point, I want you to think about the medical industry. One of the biggest threats in a medical environment is secondary infection. Someone comes into a hospital, perhaps they need surgery or they're sick with something. The last thing you want to have happen is to have them become even more ill or pass in a hospital environment because they acquired something serious from a secondary infection. And you say, okay, well, that's all well and good. So what do plastics have to do with that? Well, you can create an environment with a series of products. Virtually everything that touches a patient is a single use. And yes, you can rally against single-use plastics. I understand. But when you look at the cost involved of going back to sterilizing absolutely everything or having non-plastic items that are not single-use, the cost to the healthcare system treating secondary infections, people staying in a hospital longer, you start to understand that the use of plastics in this environment makes a tremendous amount of sense. I was actually involved briefly with a business that was tasked with trying to reprocess single-use plastics coming out of a hospital environment. And of course, there are many, many, many plastics that don't touch a patient. They're completely safe to be handled. And I still believe to this day there's a gold mine to be had there if you want to take the time to build the infrastructure to pick up plastics from a hospital. Everything from water bottles to the blue sheet, the surgical drape. That's specifically what we were looking at. The cost of not using a plastic surgical drape, going back to cloth, you're dealing with extraordinarily harsh detergents, massive pieces of capital equipment, industrial laundry machines. They are not small. They are not inexpensive to run. They are in both in terms of maintenance, hydro, everything. The soap that's used is incredibly aggressive, and that's something that goes through our waterways. So when you look at that on one hand, oh, and by the way, linen surgical drapes do not last more than about 10 to 12 times. So you've got a higher cost to buy the linen. They've got a very known life. 10 or 12 times, for example, maybe a little bit less. And if they get infected with blood, they're out right away. If you can compare and contrast those to a disposable plastic item, and yes, it looks like linen, it's a different type of plastics processing, um, and the name of it, I'm sorry, it's escaping me, but spun bond is one of them. At any rate, if you look at the linen versus the plastic, the plastic blue surgical drapes, it makes so much more sense to use that single-use disposable item. And healthcare is the number 2 generator of single-use plastics behind film and packaging, specifically for food use. Now, stop and think about food use. This is an example that I've given to actually many people who have asked me my opinion about single-use plastics and do you think it's efficient? Well, let me ask you this. If you look in your grocery store, you'll see rows and rows upon aisles of goods in plastic containers. Look at the aisle that contains your various sodas and other beverages, and probably 85 or 90% of them are in plastic. Think for a moment about the delivery trucks. And this may be something that if you're, again, outside of the supply chain, you may not actually stop to consider this. But any commercial vehicle has a maximum load that it can, in fact, carry. If it's a transport truck, it might be somewhere around 40,000 pounds, give or take a little bit. But just assume it's 40,000 pounds. If you're moving 40,000 pounds of soda or other carbonated beverages, glass is not only breakable, easily breakable, it's very, very heavy. So you've got 40,000 pounds of cargo with a ratio that's much higher of packaging to actual consumable good if you're using glass. So if you convert to a PET formed bottle, which is what you see in the 2-liter sodas, and it's so ubiquitous. If you convert your carrying mechanism of this consumer product, this soda or other beverage, to a PET bottle, you are saving a tremendous amount of money. You are saving weight. That means, in theory, you can deliver more consumable product, more usable payload on that tractor trailer with a PET plastic bottle than you could with glass, because glass simply weighs more. It's a simple argument. So naturally, it would make more sense to use plastic in that application and minimize the number of transport trucks on the road, unless, of course, you think using glass and putting more trucks on the road makes sense. But I think when you see the emissions that are coming from a diesel transport truck, well, you might think, well, maybe it's better to have plastic there. But if you said, hey, Kurt, what about an electric truck? Well, they're not happening yet. And the point is, if you consider diesel or you consider an electric truck, you're still putting more trucks on the road. So you're accelerating wear and tear on the roads with heavy transport trucks using the roads. And because they are more often than not, and you all know this from your personal experience, slower than passenger car travel, you're creating more and more traffic and bottlenecks on the road. Is this really the direction you want to go in? I don't think so. I think it makes a tremendous amount of sense to deliver your consumable goods in the safest, most impact-resistant, least likely to be damaged packaging method possible. If you just stop and look at a much wider spectrum of this problem, rather than, oh, plastics are bad, why are we doing this? Consider a wider swath of the problem. And before the items are even, the consumables are even put into the bottles, think about this. PET pellets, they're much, much lower cost to manufacture than glass. Glass takes a tremendous amount of heat, I believe somewhere around 1,400 degrees Fahrenheit. Correct me if I'm wrong, but somewhere around there. PET you can work with around 285, 300, somewhere around there. So you have less electricity used to create the movement of the material you're working with from a solid state to a molten, pliable, workable state. And since you're transforming it at a lower temperature, it takes less energy to quench it and bring it back to a solid. I'm sure you've all seen, again, if you're outside of the plastics industry, I'm sure you've all seen footage of injection molding machines or blow molding machines working. They're fast. And when it comes to glass production, not quite so fast. So it takes more energy to make glass. It takes more energy to make aluminum and steel. I mean, if you've ever looked at or heard or seen or read anything about blast furnace, you'll understand the temperature that those things have to operate at. It's thousands of degrees. So plastic all of a sudden again looks very, very attractive. After the product has been consumed by the consumer, imagine that, the consumer consumes what has to be consumed. You've got an empty thing to deal with. Well, you can recycle glass, you can recycle aluminum, and you can recycle plastic. Plastic takes energy to grind up and reuse, but it most certainly can be done. We have a company up here, Ice River Springs. They are using recycled PET in their water bottles, like everything from the small, I think the half-liter, the typical ones you'd see somebody walking around with, to the, I believe it's the 20-liter ones that go on your water cooler. So they're doing it. You can have recycled content product in an FDA-compliant environment. It is possible. Now, I think in those types of environments, you have to be pretty careful about the stream of recycle that you're handling, which makes sense. You don't want to have product that has had, a flame retardant additive or some other kind of nasty stuff find its way back into a food contact. But it can be done when the stream of recycle it is controlled, and preferably controlled by, in this case with Ice River, they're managing the entire program. So I think it makes sense. So how did we get here? You've got a material that is incredibly, incredibly cost effective to manufacture. We're drilling oil, we're pumping oil. Oil is refined into so many things. I don't think most people fully understand how oil-based products infiltrate every single thing that touches our lives day to day. And if we run out of it, we're in trouble, by the way, because we don't have replacements for most of this stuff. We don't. But for now, we have a product that is easily extracted from the earth, can be chemically modified into exactly what we need for an exacting series of applications, which is fantastic. We can do all of that. We have products that can deliver consumables to us, the consumer, efficiently with very little waste. Hey, I remember as a kid walking through grocery stores with my mom, and it would seem very frequently that a glass bottle would break, fall off a shelf, break, and you'd hear that infamous cleanup on aisle 7 or whatever the case. How often do you hear a call over a PA system in a grocery store for a cleanup? It's not very often. And that's because we're using packaging that protects the foods and beverages that we're buying. So let's talk about food waste next. I understand that many of you prefer to have reusable things like, Tupperware. I know Tupperware filed for bankruptcy. I think that was earlier this year or maybe late last year. Can't remember. But resealable containers, fantastic. Use a resealable container. Plastic works, it's great. Or a glass container with a plastic top. Fantastic. Use it. That's what they're meant for. If you get a good takeout container that's plastic, you can reuse that, I'm sure, dozens of times before something cracks and you have to get rid of. I know I do, but I make a point of trying to reuse these things because I'm sensitive to it. So be sensitive to it and reuse the plastic items that you have. But if you can imagine everything being delivered fresh, it works if you live somewhere where you can be close to a farmer's market. I love going to a farmer's market, actually, with my fiance, and we get brand new stuff. or brand new produce. It's clean. It's farm fresh. Nothing beats that. It's fantastic. But we're in a small percentage of the population that can make that work. Not everyone can. If you're in a major urban setting, going to a grocery store might be the only practical, and I emphasize that word, practical method of getting your food for the week. So you're probably going to want stuff that isn't spoiled, that isn't, damaged. It isn't. You want the food that you pay top dollar for these days to be in excellent shape, and plastic packaging is one of the ways that we can ensure that everything is delivered to you in the shape that you would expect it to be. We're not wasting food during transport. I mean, it's very rare that you'll find a load of anything, be it lettuce or fresh vegetables, that are coming from the US or any other destination, even if it's from across Canada, doesn't matter. When was the last time you actually had something that was really damaged? I mean, probably not. Maybe when you get it home, there was something you didn't see in the supermarket and, oh darn, something 50% of it's bad or a third of it's bad or a few leaves of lettuce aren't great and you didn't happen to see it when you picked it up. Well, that can happen, but a completely destroyed piece of produce, no, it just doesn't happen. It just doesn't. And that's partially because plastics are keeping the contents fresh and partially it's just keeping airborne contaminants from touching the produce. Okay. I mean, that's the biggest thing that they're doing. Creating a refrigerated environment I think that has been the most critical thing to ensuring that we have good, healthy, safe food. Refrigeration. Secondly would be packaging that food so it stays fresh, clean, and out of airborne contaminants. And that's the role of plastic packaging. Now, think about things, I talked about healthcare a few minutes ago. How about pharmaceuticals? Would you buy a package of anything, pharmaceuticals, vitamins, anything along those lines that were not delivered to you in a tamper-proof plastic container? I mean, many people listening to this, they may be too young to remember what happened with Tylenol. I think it was in New York or New Jersey, where some crazy deranged person spiked bottles with cyanide. I think that was it. And now we have tamper-proof plastic for plastic jars and blister packs for virtually everything that's pharma in nature, as it should be. We need quality guarantees that what we buy and are going to consume to remedy something that is wrong with us isn't going to kill us or hurt us in the process. So, and from a pharmacist standpoint, being able to sell packages of things, it speeds up their process. So you have potentially lower costs in medication delivery. That might be a stretch, but still getting the product in the hands of the person who needs it, ensuring it is tamper-proof. I mean, come on, that's a slam dunk for plastics. You're not going to find any other material where that works. Next, let's talk about my favorite subject, automotive industry. I love cars. Before recording this podcast, I was working on one of my project cars. So this podcast is being recorded a bit later. I had to do some work before I lost my daylight. And I still lost daylight, but I wrapped up the project. Think about all the safety systems in a car, from airbags, that whole thing. The airbag itself, I believe that's nylon or some other type of material. You're not going to have a cotton airbag go off. I mean, seriously, it's a synthetic material. The things that we have in the car for weight reduction, which is going to be more and more prevalent as we continue a transition to alternative energy vehicles. I don't have 100% faith in pure EV. I think we're heading, the end game is a hydrogen economy, in my opinion. But if you look at EVs, I think you know full well that a battery weighs an awful lot, like 12, 15, 1600 pounds. So if you're adding that kind of weight to a car's structure, you better be looking for ways to subtract weight. Weight, mass, whatever you want to call it, I know they're two different things, but mass is the enemy of fuel economy and handling. And you can create an EV and to do all these things, but to satisfy consumer demand, it should handle reasonably well. And you should also be able to drive yourself out of a bad situation. An evasive maneuver is what I'm referring to. So you've got to take weight out. Now you sort of juxtapose that against the safety features we've had to add, and comfort and convenience features, sensors all around a car, park assist, for example, or adding cameras around a vehicle to, again, assist with parking. What other things? All your safety systems, the switch gear, little boxes to hold circuit boards. All of this is the realm of plastics. Can you imagine die casting these things, the weight it would add to a vehicle? It would be ridiculous. You could be adding hundreds of pounds just in non-plastic materials. So we absolutely need plastic to further weight reduction and weight control in a vehicle. Now, you could also talk about the aeronautics industry. I'm not very well versed in that, but I could tell you nobody is looking for things to add weight to a commercial aircraft. So if you're going to be looking at applications for weight reduction with certain strength and performance criteria, you can bet plastics will be a part of that. They just have to be, because we can custom tailor everything that they do so finely to an application, it's not even funny. And that is really what brings us to, where are we with plastics? How did we get here? You've got a commodity that is so cost effective to work with, from its creation to its forming to its recycling. It is cost effective. We have a commodity that can be custom tailored to virtually any application that we want. Say for certainly some things where metal still rules, be it steel or aluminum or an alloy. I get it. There are many instances where it just works, and there's economies of scale, thinking like car bodies and whatnot that are stamped steel and have high strength steel and in certain elements of the safety structure. I get it. But think of how many plastic bits there are in a car. And if they weren't plastic, they would add cost, they would add weight, they would subtract fuel economy. So you've got that. And then you have the whole supply chain of extracting oil. And that allows for economies of scale in this commodity, the likes of which just don't exist too many other places, with the exception of maybe metal, because we've been at it with metal for a little bit longer than plastics. And I understand that. So you have economies of scale. You've got ease and low cost when it comes to working with this particular commodity. And you've got a family of materials that can be custom made into just about anything. This is how we got here. This is an industry trying to do something on purpose to shove its products down your collective throats. No, we built something better. It's up to us to manage this resource, to not litter, to practice recycling, to get government involved in more methods of recycling. We can't let this just fall off the table. It's an important commodity. We have to treat it with respect. And being in the industry, I'm a strong advocate for it. I've tried with business to do that. It's not easy. It requires deeper pockets than I had, and I fully admit that. But that doesn't mean that there are other companies that shouldn't be taking up the challenge to recycle as much of everything as possible. There are so many applications for recycled materials that you're not even aware of. And it's okay. We can park materials in different levels of, well, I would say different applications with different demands, I think is the best way to put it. We can find recycled materials in different levels of demand, different physical property characteristic demands. We can do it. We know this. We can do it. Don't give up on recycling. Don't give up on plastics. Understand the full spectrum of supply chain and why we are here. And it's a natural evolution as to why we are using plastics. Does that mean we can't be better with their use? No. I encourage everyone, don't consume what you don't need. Recycle everything you can. If you can find something, repair it, and get some more life out of it, do it. That's the reuse. What is it? Reduce, reuse, recycle. It makes so much sense. Don't buy garbage. Don't buy garbage. We got a lot of work to do, but don't blame plastics. Don't blame plastics. It's us. It's us. We demanded solutions to life problems. We got them. Now we have to deal with the consequences of those materials and manage them. That's the right way to do it. So there we go. That is the end of this particular podcast. I hope you found this to be somewhat, insightful, maybe gets you thinking. Consider your own spending habits, buying habits, consuming habits. Do what you can to be responsible with everything you have. That's all we can do. And there's over 8 billion of us here. So if we all pitch in a little bit, maybe we'll get there. So if you have questions or comments or suggestions for upcoming shows, please feel free to reach out to that plastics guy. That's me on LinkedIn. And I'm there personally too, of course. So one way or the other, reach out to me. Please consider following that plastics guy on YouTube. Like, subscribe, share, all that good stuff. Simcoe Plastics is also on Facebook and Instagram. And you can subscribe to our newsletter through the website. We just sent out kind of a fun September back to school one about 3 weeks ago. So that's something you may want to have a look at too. Thanks again for listening. Think about what I said. We only have one world. We've got to take care of it. And that means taking care of the commodities and everything we use to live day by day. Be good to each other. Bye for now.